So I want to show you some strategies for factoring special polynomials. So there are two. The first one is difference of squares. So difference of squares, this is going to be a binomial. So two terms. And it's always going to have the frame that you have something squared minus something else squared. Okay? So minus for the difference, squares, that everything's squared. Okay, so before we get there, though, my little lead in here. So just to show you, it's like, oh. So let's go ahead and practice multiplying. So x plus 1 times x minus 1. What do we get when we multiply those two polynomials? So, right, you get x squared minus x plus x minus 1. So what happens to the middle term, right? So negative x plus x, those guys go away, and we just get x squared minus 1. Let's do the next one. X times x is x squared. X times negative 7 is negative 7x. 7 times x is plus 7x. And then minus 7 times positive 7 is minus 49. So again, a negative 7x and a positive 7x add away. So when we multiply, x squared minus 49. So the only time we kind of get to this place where we don't have the middle term, where we multiply two binomials and get a binomial, is when they're conjugates like that. So conjugate is the math word. Same two terms, opposite sign in the middle. Okay, so the next one. Do you want to try to do it without foiling? Do you see what's been happening? Okay, so I'm going to go ahead and FOIL, and then you can check. So 3x times 3x is 9x squared. Right, make sure you get the 9 there. Then we'll get a plus 24x, and then we'll get the minus 24x, just like they're supposed to, and then minus 64. So this product is 9x squared minus 64. So notice my products on all of these have that special form for the difference of squares, right? This first term here is 3x, quantity squared, minus that last term is 8 squared, right? So then this one here, right, that was just an x squared minus a 7 squared. Now, here's what I want you to pay attention to. What is here in the parentheses squared and how that looked in the factored form, right? Because now that's what we need to do. We need to go from the binomial, right, the difference of squares, to what the product would be, right, that we multiplied. So we're just going to see if we can work this pattern backwards. So x squared minus 36, right? So this is, right, x squared minus 36 is 6 squared, so right, another perfect square. So how that factors then, right, you get an x plus 6 times an x minus 6. So conjugates, same terms, opposite sign. And again, you can always check if you multiply. So x squared minus 16. Difference squared. So I have something squared minus something else squared. So that's going to be x plus 4 times x minus 4. Okay. Now you might be tempted. Be careful. You might be tempted to say, oh, well, that's x minus 4 quantity squared. But it's not. And you can check by taking x minus 4 quantity squared and multiplying it out and showing that you do not get back to this guy here, to x squared minus 16. Okay, last one, 9x squared minus 100. So the 9x squared can be a little tricky, but we just did one of those, so just look up there. So what goes in the first spots? Yep, 3x, 3x. And for the 100, that'll be 10, and you get one with a plus and one with a minus. It is absolutely okay. I can hear somebody wanting to ask that. Could I have written the negative one first? And you sure can. Just make sure you have one minus and one plus. Either one of those is fine. So in general, if you have a squared minus b squared, that factors into a plus b times a minus b. Okay, so that's one of our special forms. It's something to look for binomials. Okay. Be on the lookout, though. It has to have that exact form. Something squared, a minus, and something else that can be written squared. You can't have anybody else hanging out, like afterwards, no plus or minus, like anything at the end. Something squared minus something else squared. Okay, here is our next special polynomial, and that is a perfect square trinomial. Ooh. So a perfect square trinomial means you've got a trinomial, and when you factor it, you get something squared. So again, we're going to lead in with a multiply. So let's go ahead and do x plus 3 quantity squared. Let's see what that turns into. All right, so we know that that means x plus 3 times x plus 3. And we can FOIL. So we'll get x squared plus 3x plus 3x plus 9. So x squared plus 6x plus 9. Okay. Now I need you to keep one eye on that end answer, right? Because what we need to do right before we're done here is we need to be able to see x squared plus 6x plus 9 and get back to x plus 3 quantity squared. Okay? All right, let's do the next one. So x minus 6 squared means x minus 6 times x minus 6. We'll get an x squared minus 6x minus 6x plus 36. So x squared minus 12x plus 36. So let's just see what we notice about those three terms that we have. Okay, so that last term, right, is 6 squared, and it's positive. Okay, the minus 12, right, is 2 times x times the 6, or the negative 6. And the x squared is that first one squared. So does that work for this, the one we did before? So x plus 3 squared, the 9 is 3 squared. 6x is 2 times 3 times x. Okay, that's true. X squared, okay, that's true. Let's do our last one. X plus 7 times x plus 7. What does that one turn out to be? I'm going to hit the focus button. It's looking a little fuzzy to me again. So what do we get? Right, so x squared, I'm not going to FOIL it this time. I'm just going to write it. X squared plus 14x plus 49. So again, we have a nice positive perfect square at the end. We have 3 terms. And then this middle coefficient is 2 times the square root of that constant term. Okay, so that's kind of what we're looking for. It's like, gosh, does it? Right, it can just be this guess thing. Does that one work? Right, and then we check to make sure. So let's factor the perfect square trinomials. So first we're going to take a quick look, make sure, right, we fit the bare minimum criteria. So trinomial, 1, 2, 3, yes. And then for sure, right, I need an x squared, and for sure, I need a perfect square for my constant term. So I have that here, right? X squared, nice perfect square. 25, nice perfect square, right? That's 5 squared. So then maybe I'm just going to do a check. Is this, so this is a guess, is this x plus 5 squared? Right? So I know I'm going to get my x squared. I know I'm going to get my 25. Do I get my 10x? Well, this is my guess. So then we could do just a little quick check. If I square x plus 5, do I get back where I started? X squared, 5x plus 5x is 10x. 5 times 5, 25. Yep, I do. Okay. What about my next one? A squared minus 24x, a, make that an a, everybody, plus 144. Okay, so trinomial, 1, 2, 3. 144, it's a nice perfect square, right? 144 is 12 squared. Okay, so now we just have to see, are we going to get that middle term, right, if I do perfect square trinomial? So that would be a, right? And then for my second part, I need the 12, right, so that when I square it, but I need the same sign that the middle term had. So a minus 12 squared. And again, it's kind of a guess at this point. And now we're just going to make sure we get back to that 24. So is a minus 12 times a minus 12, does that get me back? Okay, so a squared, yes. Now let's check the middle. So outer is negative 12a minus 12a, yes, negative 24a. And then finally, it is negative 12 times negative 12, positive 144. Yep, that'll work. Okay, last one. I bet you can write that one down. So x minus 3 squared. So you have to have a little squared there, or you can absolutely write it, right? This is also factored form. Either one of those forms is totally fine. Okay, so in general, for recognizing, well, it's kind of hard to recognize a perfect square trinomial. 3 terms, something squared, a positive something squared on the end, and then you just kind of want to check that middle term. Now, the thing that you might find really helpful, though, is if you have to square a binomial, what that pattern is the first thing squared plus 2 times, right, the 2 pieces on the inside. So a plus b squared is a squared plus 2ab plus that last one squared. Okay. Oh, so I guess that would be another quick check, like just, is it even worth looking for? So perfect square at the front, positive perfect square on the end, and then that x coefficient has to be an even number because it has a 2 times in it.